Part 3 of Lecture 2 is about the wireless network topologies and cellular network. Like the wired network, we have two types of network. We have infrastructure and ad hoc. In infrastructure network is more centralized topology, and ad hoc is basically distributed topology. Infrastructure topology has a fixed infrastructure supporting the communication. There is a large coverage area with the multiple base stations. All communication from mobile terminals is to go through a hub, and the hub is the central controller. Example of this topology for wireless is cellular mobile network. And that's an example, that's a picture of infrastructure-based network. Ad hoc network is when devices are connected to each other and not a central controller exists. It's suitable for rapid deployment. If the devices are directly connected to each other, it's called single hop network or single hop ad hoc. If devices need to connect through a couple of other devices to get to another device, it's called multiple hubs. So in the single hub, all devices are connected to each other, and in multi-hub, they communicate with other to get to the certain device. Every node must be aware of the neighboring terminals in the ad hoc network. And that's an example of ad hoc network basically. So the first one is the one on the left. This one is a single hub, and this is the multi-hub. So to get from WT1 to 3, it needs to pass 2. But here, it can just connect to each other with one hub. If we compare the two topology together, in terms of controllability, some features need to have central control ability, like synchronization, transmission power, and other stuff. We have that in the infrastructure network, but it is missing on the ad hoc. It's still doable, but it's more complicated, and distributed structure is required. The routing complexity. In multi-hub ad hoc network, each terminal requires to monitor the existence of the neighboring terminal. Distributed routing protocol is required as well. In infrastructure network, just one hub away, basically because all the devices are connected to the hub. And that hub can be or router or access point or base station, does all the routing stuff. In terms of coverage, in a single hub ad hoc network, the range of the coverage is basically the range of the transmission of the device. But in infrastructure network, twice the range of the coverage of the transmitter. So two mobile devices communicate through access points normally. That's why they all go to the hub, so we can cover more area. In terms of reliability though, ad hoc network is more reliable, but infrastructure network has the single point of failure or single failure point network. Store and forward delay. In the single hub ad hoc network, there is no delay because it's directly connected to another device. In the infrastructure network, it's stored in base stations and access points. And in multi-hub network, it stores in each relay node. The cellular topology, there's some requirement for cellular topology. The frequency reuse is happening in cellular topology to increase the capacity. By cellular radio, it means that deploying a large number of low power base stations for transmission, each having a limited coverage, so they need to cover the cell area basically. Available capacity is increased each time a new base station is set up. The cell structure implements the space division multiplex, and base station covers a certain transmission area called cell. Mobile station communicates only via the base station. The advantages of cell structures is higher. It has the higher capacity, higher number of users, less transmission power needed, more robust and decentralized. Base station deals with the infrastructure, transmission area, etc. locally. But the problems are the fixed network is required for the base station. The handover between the different cells, so if the mobile devices is moving between the different cells, the handover technique needs to be used. And there can be interferences between the other cells as well. The cell sizes start from 100 meters in the cities and goes to the 35 kilometers on the countryside, or even less for the higher frequencies. It depends on the frequency. And the cell structure. In the cell structure, we always use hexagon. But why we are using hexagon? Because it's not easy to do it in the real world. And something like circle or square is much easier compared to the hexagon. But as you can see in the circle area, if you use the circle, there are areas, these blue areas, that's not covered. And if you want to cover, the circles are going to have overlap. And since we are going to use this different frequencies, it's going to be more interferences here. And if you compare to the square, there is no overlap in a square either, so the area can be covered, but there is less hexagon shape is required to cover the area compared to a square. The frequency reuse becomes possible using this shape only. That's why. The radiation pattern of the antenna uses a 60 degrees, which means 6 angles or 6 corners is required in the cell to cover the full 360 degree for the coverage, which is exactly the same number in hexagon. There are a couple of principles in the cell structure. It's divided the coverage area into number of contiguous, a smaller area called cells, each served by its own base station. So in each cell we have the base station and covers that cell. Radio channels allocated to these cells to minimize the interferences. Group cells into cluster. So when we have group of cells, we call it cluster. Each cluster utilizes the entire frequency spectrum. Adjacent cell cannot use the same spectrum because of the interferences. Two types of interference we have core channel and adjacent channel. In the core channel, it happens due to using the same frequency, and adjacent channel interferences from different frequency channels. The frequency planning, if you want to decide on the cluster we have or the cell structure we have, frequency reuse only with a certain distance between the base station. So we're not able to use the same frequencies for the adjacent cells. The standard model has the 7 frequencies. We have two types. We have fixed frequencies assignment, which certain frequencies are assigned to a certain cell. The problem is that the different traffic loads in different cells. The dynamic frequency assignment, however, in that base stations choose frequencies depending on the frequencies already used in the neighboring cell. More capacity in cells with more traffic, and assignment can also be based on the interference measurement. And this is some of the examples if the size of the standard model is the 7 frequencies, if you use 3, 7, 9 or 4. To reuse the same frequency, we need to calculate the reuse distance, or D, by multiplying the radius of the hexagon, or R, with the root of the the frequency times 3, and the reuse factor is D over R. We have the reuse factor here again, and a cellular tiling pattern can be presented using two non-negative integers, I and j. The integer I is the number of cells to move from one cell in one direction. Then you need to turn 60 degrees counterclockwise and move j cells in the new direction. So that's basically the rule here. This is an example of calculating that co-channel cells. So if I is 2, j is 1, then n is 7. For a cell A moving 2 units along one face, of the hexagon and 1 unit in a direction of 60 degrees or 120. So if I pick the pen here, and this is the A, we go one face, sorry if it's not straight, for 2, because I is 2. And we need to go one cell in 60 degrees. So if roughly that's a 60 degrees, we go one cell and you can see there's an A here. So if we go to the other side, like this side, for example, we go that way. That's 2 cells because I is 2. And 60 degrees anti-clockwise, so that would be A again. So if you can do the next one at home and try to fill in these cells with 1. So if 1 is a frequency, find the co-channels in this picture based on the I and J, and calculate Q as well. Let's say if N is 7 as well. SIR, or signal to interference ratio, is another important factor we need to calculate in wireless communication. The information is given here. These are the formula you need to calculate it. If you need more information on how to do it, there's a YouTube link here and you can follow that.